Hi there, this is Raju. Welcome to my channel, that is Java Tutorials World. In this video, I am going to explain about what is JDK, JRE, JVM and JIT Compiler. If you are a beginner or if you are a Java developer, you must be heard about all these terms. In general, either people feels that all these words are same or they get confused between all these words. I will provide a detailed explanation about all these words. Let's start with JDK. JDK stands for Java Development Kit. JDK contains software components that is used to develop Java-based applications. Let us suppose if you are a Java developer or a Java learner, you must need to install JDK on your machine to write your own applications or to write your own programs and to compile them. I made a dedicated video which explains about how to install JDK on Windows and Linux operating systems. I will add that video URL into YouTube's description. You can refer that for more information. Just to run already compiled programs, JRE is sufficient. That means in general, for end user, JRE is sufficient. JDK contains Java development tools plus JRE. Means if you install JDK on your machine, you will have everything to develop and run Java application. Let's see what are all the tools that are part of JDK. First, we will start with Java compiler. We can find Java compiler if we go to Java installation directory. Inside Java installation directory, if we go to a folder called bin, we can find Java compiler there. And Java compiler is responsible for converting source code into bytecode. Means like a Java compiler is responsible for converting .java file into .class file. And this Java compiler can be accessed by using a command called javac. And this Java compiler is also responsible for processing annotations which are part of Java source file. Let's see the next tool called Java interpreter. This Java interpreter is responsible for converting .class files which was generated by Java compiler to machine understandable language. This Java interpreter can be invoked by using a command called java. And this Java command starts the application by starting JRE, that is Java Runtime Environment. The next tool is Java documentation, which is part of JDK. This Java documentation tool, which is part of JDK, helps us to maintain the code. Whatever commands we write inside this Java source file, this Java documentation tool parses that information and generates corresponding HTML file. I will make a dedicated video about this Java documentation and how to write Java comments and how to generate this Java documentation. I will make a dedicated video. Actually, this entire Oracle documentation was generated by using this Java documentation tool only. The next tool is Java Disassembler. This Java disassembler can be invoked by using a command called java-p, and this Java disassembler disassembles one or more Java class files based on the options that we pass it to that disassembler. We will see how to disassembles one or more classes and what are all the options available. Let's open command prompt. If I type a command called java-p, we can see these are the options that are available in Java disassembler. This first option prints this Java disassembler's version. If we pass a class name without any options, tutorials Java. If I pass this particular class to this disassembler, it will directly print this outline of this class. If we see this information, it's clearly telling that it was compiled from first Java program.java, and it is also printing that class name and a constructor, a public constructor, and the method name. We can pass with fully qualified path of this class, or we can go to that particular directory and directly we can pass something like this java p and our class name, and that's also results the same. And if we open this file, we can clearly see that .java file. This is the source file. This is the uh, main method, and it's printing the same information here. And if we see the other options, Java p hyphen help, you can see the other options. Like there are options like verbose. Actually, this verbose option prints this verbose option prints this information like minor version and major version, and this stack information. Actually, in stack, at which place this constructor was, it's printing that, and local information, the argument size, and the other methods. Like if you see, it's printing the other method also, that main method also, and what is the access specifier of this, and these flags like this, since this method is static method, it's printing acc underscore static, and this is placed at second place in stack, and this is one more argument. This has only one argument. This is the information that this verbose prints. And if we see the other options, if we go here, like if we see the other options, we can see like if we pass this public to java p public, and if we pass class name like this java p public hyphen class name, it prints all the public members in this particular class. And if we pass this protected, in the similar way it prints protected members as well as public members in that particular class. And if we pass package as an option, it will print package and protected and public classes. And if we pass this private as an option, it will print everything like show all classes and members. And if we use this option like java p hyphen c first program.java, we see this option, it prints the total bytecode information by using this command. And if we see the other options like signature, This prints java p hyphen has first program dot class file. If we see, it is clearly telling again like this compiled from first program.java, and it printing the signature of these methods. Like if you see, this signature is clearly telling that it has one argument which is of type string, java.lang.string. Like that, this signature will provide information, and java p hyphen sysinfo, it prints like a class file path and last modified every information, checksum, and where it was compiled, and this brief information of this particular dot class file. It's printing this sysinfo printing this information. And if we go to the other options, like this constants, prints all the constants that are as part of our dot class file, public static final constants it will print. And this class path, like if we set this like this indicates that where this particular disassembler need to look for dot class files. If we set this class path, from there it will pick all the dot class files to disassemble. And these are the various options that are available with this disassembler. The next tool as part of JDK is Java header file generator. This Java header file generator can be invoked by using Java H command. This Java H generates C header and source files that are needed to implement native methods. Let's see this how to generate Java header files. Let's go to command prompt. This Java H, this command generates header file for given dot class file. So Java H space class name. Our class name is first Java program. This Java H space this class name generates Java header file. If we go to this directory, we can see that a header file was generated. Now we will see the options available with Java header. This Java H hyphen help will show the options that are available with this command. These are the options available with Java header. By default, this Java H space this class name generates header file into current directory. We can change that by using Java H hyphen D, and we need to specify the directory where we want to generate this header file. Just I am writing a folder called test, and I am giving my class file name. If this test folder doesn't exist inside this C drive, this Java H command will create this folder and places this header file into that particular folder. And the next option is this verbose. This verbose will provide verbose output. We will see that also as part of this example. Java H hyphen D, and that folder name I will write this hyphen verbose here. So we will see this verbose is giving this particular information, and this hyphen D will create a folder called test, and this header file will be placed inside that particular test folder. Let's see that. If we go here, like we can see a folder called test. Inside test, this header file was generated, and if we go to other options, this hyphen version will print version information of this particular header, Java header. We will see that also, Java H hyphen version. So it's showing the version of this particular Java header. And this JNI will generate the header file in JNI style. Actually, by default, this will be the option. So we need not use particularly this JNI as an option. And this force always provide output files. If you use this force, this will always generate output files. And this class path is one more option. Actually, this class path is the path where this particular Java H need to search for the files that need to be generated as headers. Actually, by default, this class path is our Java class path. So we can use default classes to generate Java header. So we will see that also. Java.lang.string. So we can see that Java header was generated here for this current directory. This is the current directory. For this current directory, this header files was generated for string class. These are the options that are available with Java H. The next tool that is part of JDK is Java Debugger. This Java Debugger can be invoked by using JDB, and this is a simple command line debugger for Java classes. There are many ways to start this JDB session. One of the way is JDB space this class name. When we start this JDB in this way, a separate JVM will be invoked as part of this. The another way to invoke JDB is by attaching it to a JVM that was already running. This is the syntax to attach this JDB to existing JVM. These are the different tools that are available with JDK, that is Java Development Kit. And this completes the tools that are available with JDK. Next, we will see what is JRE. JRE is an implementation of JVM which actually executes Java programs. It includes the JVM and core libraries and other additional components to run applications and applets that are written in Java. For the end user or for client, this JRE is enough because just they want to run the applets or the applications that are written in Java. JRE is smaller than JDK because it doesn't have software tools that are needed to develop Java programs. JRE just have environment to run Java programs. And we will see the differences between JDK and JRE. JDK is a bundle of software that can be used to develop Java-based applications, whereas JRE is an implementation of Java Virtual Machine which actually executes Java programs. JDK is needed for developing Java applications. JRE is a plugin needed for running Java programs. This JDK needs more disk space than JRE because it has JRE, along with that it has various development tools. But whereas JRE needs less disk space because it doesn't have development tools. These are all the differences between JDK and JRE. Now let's see what is JVM. As we all know, when we compile a source file, a dot class file will be generated, which is a bytecode internally. This bytecode is not mission understandable. So JVM interprets this bytecode into mission understandable language depending upon underlying operating system and hardware combination. JVM is part of JRE and it doesn't available separately. And this JVM is different for different platforms. So JVM is platform dependent. Now let's see what is JIT compiler. Initially, Java has been accused by poor performance. To improve the performance, JIT compiler was introduced. This JIT compiler is a component of JRE which improves the performance of Java applications at runtime. In general, this .java file converted to .class file and this .class file compiles and interpreted by JVM. Don't confuse. Actually, I'm using this compiles word because this bytecode is converted into mission understandable language. So it definitely takes more resources. So to improve the performance, JIT compiler was introduced. This JIT compiler compiles the bytecode of a method into mission understandable language and compiles it in just in time. When a method has been compiled, just JVM calls compiled code directly. So this improves the performance of Java application. This JIT compiler is enabled by default and activated when a Java method is called. The JIT compiler can be disabled in which case the entire Java program will be interpreted. Disabling this JIT compiler is not recommended. Let's summarize the entire discussion with this diagram. JDK contains tools like Java compiler, Java interpreter, Java documentation, and Java disassembler, Java debugger, and Java header file generator, plus lot of other tools. JDK contains all these tools plus JRE. JRE contains library classes plus JVM. And finally, JVM contains JIT compiler. I hope this clears what is JDK, JRE, JVM, and JIT compiler. That's it for now. Thanks for watching my video. Please subscribe to my YouTube channel.